So here's how to name polyatomic ions. Whoop, where's that thing? Sorry, not how to name polyatomic ions, but ionic compounds with polyatomic ions in them. It's actually pretty easy once you've done the sort of not fun, not easy task of memorizing all of the scary looking polyatomic ions, but essentially you just kind of say what they are. So example here, this is still an ionic compound because that has a positive charge, that ammonium polyatomic ion. This has a negative charge, so it still acts as a polyatomic ion. So does, an ionic compound. This too, sodium gains a positive charge, hydroxide is a negative charge. So even though they look messier than the binary ionic compounds, they're still just regular old ionic compounds. So basically you just say the names of them. So ammonium chloride, so just like the binary ones. But the thing is like, so for example here it's even easier. You just say sodium and then the name of it. Hydroxide. Potassium permanganate. This is ammonium sulfate. And do note that if you were going back and forth between the name and the formula, you would say here, okay, well, ammonium, that has a charge of +1. Sulfate has a charge of -2. Okay, so again, the ionic compound is itself neutral, so meaning there must be 2 of these guys to offset the sulfate ion, so meaning, and remember when you're sort of saying that there are 2 of these polyatomic ions, you got to use parentheses. So that is the thing. Hey, and look, it's right there. Oops. All right, so should we move on to the next thing? Yeah. All right, so now, another type of ionic compound. This is still an ionic compound because how come? Metal? Non-metal. All right, but the thing here is that the transition metals, that is, if your periodic table looks like this, hopefully it doesn't. That is a sad looking one. But the transition metals, almost many of them can accommodate more than one oxidation state or charge when it's in an ionic compound. So, for example, iron can have an oxidation state or a charge in an ionic compound of +1, +2, +3. So you need to make sure that it's stated what it is. So for example, how do we figure that out? Well, bromine, if it's an ion, which it is here, bromide has a -1 charge. You know that because it's in the 7th group, and those guys tend to gain a charge of -1. You can use the periodic table to determine that. There are 3 of them, so meaning the bromide part of this ionic compound has to be contributing a charge of -3. There is only 1 iron ion in this, so if this whole thing is neutral, the charge of it must be +3, okay? Now, you need to state that in the name of it, and the way you do that is with stock numbers, which are the Roman numerals that represent the charge on the transition metal, okay? Please note that it doesn't represent the number of iron atoms or iron ions that are in the compound, or in one formula unit of the compound, that it's representing the charge on that. So let's have an example where we go back. How about if it were iron 2 bromide? Okay, is that an ionic compound? Check, because it's metal and non-metal. All right, now what's the charge on the ion of the iron ion? +2. The bromide one, -1. So that would mean that the formula for iron 2 bromide would be FeBr2. Okay, hope that helps.